On the 18th of February, after years of development and an 8-month-long journey, the Perseverance rover finally made it to Mars to begin its mission, investigating whether Mars had harbored life in the past. However, the Perseverance rover was not alone in its journey. The Ingenuity drone that accompanied the Perseverance is the first man-made powered flying object that we have sent to space, and its importance in the future of spaceflight cannot be understated. The engineering that made it possible is something to behold. The main goal of the Ingenuity drone was to be a technology demonstration and prove the feasibility of powered flight on another planet, nothing more. It was intended that the drone perform up to 5 test flights in a 30-day period, demonstrating its capabilities and gathering valuable flight data for future missions. 7 months after the Perseverance arrived on Mars, the drone has flown 13 times and has flown for a total of 2,830 meters as of September 4th and shows no signs of slowing down. Flying on the red planet is a challenge on its own. Initially, some people might actually think that flying on Mars is easier than on Earth. Weaker gravity means that gaining altitude requires less energy, right? Less force pulling you down. Well, not really. Even though it is correct that the force of gravity is less on Mars, the atmosphere is also much thinner on Mars. It's so thin that the atmospheric density on Mars is only 1% of the atmospheric density that is on Earth. Drones and helicopters work by creating rotary motion on the blades, which pushes air downwards, thus creating lift. When the atmospheric volume is less than 1% than that of Earth's, it becomes very difficult to get the drone to fly since you don't have air to push down and create lift. This difficulty is despite the reduced force of gravity. In order to address this, JPL engineers had to design a drone that not only spun its blades faster in order to create more lift, but they also had to make the drone as light as possible. Thus, the rotors on the Ingenuity drone have a rotor speed of 2,400 RPMs, around 5 times what is needed on Earth. Weight was also a massive barrier in designing the drone. To get the Ingenuity drone to fly on the Martian surface, the weight of the drone had to be reduced to just 1.8 kilograms. In order to decrease the weight of the Ingenuity drone, JPL engineers decided for the drone to have a battery capacity of 130 to 140 kilojoules of energy, with a weight of 273 grams. To put that weight into context, an iPhone 12 Pro with a leather case weighs 278 grams. This is enough for a 30-second flight, which is short, but it's more than enough to demonstrate flight on another planet. The drone was also fitted with 4 carbon fiber blades, which also serve to reduce the weight of the drone. Carbon fiber is a material that has recently been heavily used in the aerospace industry due to its low weight and great strength. JPL engineers also decided not to put any laboratory equipment on the drone to keep the weight lighter and the energy consumption lower, as most lab equipment was already on the Perseverance rover and there was no need to add it onto the Ingenuity drone. The Mars helicopter is equipped with antennas that communicate with Earth and with the help of the Mars rover and Mars orbiters. The body of the drone also has insulation material to help protect the avionics or the brain of the helicopter from the extreme cold temperatures on Mars. It also has ultralight legs that are made of carbon fiber that are not only strong but are also lightweight, further reducing the weight of the drone. Another interesting fact about the Ingenuity drone is that it uses a Snapdragon 801 processor. This is the same processor that you can find on a Samsung Galaxy S5, which was made back in 2014. The Ingenuity already successfully demonstrated that flying on another planet is possible. The future is likely to hold other robotic flying devices, part of other missions on Mars, and hopefully this future comes sooner rather than later.